This is the first test, chapter 1, the chapter 1 and 2 test problem number 3. Chapter 1 and 2, problem number 3. And the first one is just a plug it in, number in, number out. The question has come about is, how do you use L'Hopital's rule? Because the limits, you have an option as to whether or not to use L'Hopital's rule if it applies. So actually B, C, and D are all three L'Hopital rule problems. And if I plug in 2/3, this is 4 minus 9 times 2/3 squared over 3 times 2/3 minus 2. I'm going to get a 0 over 0 form. And a 0 over 0 form is L'Hopital's rule, so I can use L'Hopital's rule. And that says, now moving L'Hopital's rule, LHR, this becomes the limit as x goes to 2/3. The derivative of the numerator, derivative of 4 is 0, minus the derivative of 9x squared is just 18x. The derivative of 3x is just 3. The derivative of negative 2 is just 0. So this becomes the limit as x goes to 2/3. I'm just going to simplify this, of negative 6x, which is negative 6 times 2/3, or negative 4. So that's how you would use L'Hopital's rule in that particular problem, where before what you had to do is algebra.
Wasn't there like 3 cases? Like 0 over 0?
0 is 0 over infinity. The next one is infinity over infinity. That's this guy. And so if I put in infinity, this would be 2 infinity squared plus 2 infinity minus 5 over 3 infinity squared plus 1. That's an infinity over infinity form. So that means I can use L'Hopital's rule. So using L'Hopital's rule, this becomes the limit as x goes to infinity of, derivative of the numerator is 4x plus 2. Derivative of the denominator is just 6x. But now if I plug it in, this is 4 times infinity plus 2 over 6 times infinity. This is still infinity over infinity. So I've got to use L'Hopital's rule a second time. So this is the limit as x goes to infinity of just 4 over 6. That's just a constant. So it's 4 over 6 or 2 over 3. And then the last one is another infinity one. It's 2 times infinity cubed plus 5 times infinity minus 1 over 2 times infinity to the 5th plus 4. That again is infinity over infinity. So I can use L'Hopital's rule on it. So this then becomes the limit as x goes to infinity of 6x squared plus 5 divided by 10x to the 4th. Well, unfortunately, if I put infinity in again, that's going to be infinity over infinity. So I have to use L'Hopital's rule again. So this becomes the limit as x goes to infinity of 12x divided by 10x, it's not, 40, I can fix that, 40x cubed, which is the limit as x goes to infinity of, reduce it down. I don't care about 12 and 40, that's not the problem. This x reduces out with one of those two. This gives me a 12 over 40x squared, which is 12 over 40 times infinity squared, which is 12 over infinity, and 12 over infinity is 0. Ben, I think we've got it. So those are those limit problems using L'Hopital's rule. You don't have to use L'Hopital's rule, but if you want to, you can.